Hi, my name's Gavin Wilkinson and I'm from AnyLogic. Welcome to our material handling webinar. The team presenting today includes Anand, Managing Director of DSE, Kelvin, one of DSE's in-house AnyLogic specialists, who focuses on deep reinforcement learning, and Jock, Director of Growpura, a hydroponic technology company that's focused on solving the problems and challenges of large-scale hydroponic farming systems. We hope you enjoy the webinar.
Gavin, thank you very much for the introductions. Hi everyone, my name's Anand. I'm from DSE Consulting and welcome to this AnyLogic webinar. So today we're going to be talking a little bit about the Material Handling Library, also known as MHL, and we're going to be showing you some of the simulations that we've built from within that library. This is going to lead us into an application of MHL that we did with a company called Growpura. So it's a proof of concept model that we built for them, just looking at some of their innovative agri-tech factory processes and also some of their equipment. So this webinar is aimed at beginners and intermediate AnyLogic users, those who are really looking to either start using the MHL or get more out of their current MHL models. It's also for expert users who might find some of the new aspects of the updated MHL really interesting for enhancing your existing and future models as well as your workflows. So we'll start by providing an overview of AnyLogic as a simulation platform, DSE as a technology partner, and Growpura's hydroponic solutions. We'll then touch on the new features broadly within version 8.6 before jumping into some of the new material handling library specific features that are coming out. Lastly, we'll be showcasing some of these features that have been applied in the Growpura's material handling simulation, and then we'll switch into live mode for a quick Q&A to talk a little bit about what we've done and answer some of your questions. Although many of our attendees on this webinar probably know AnyLogic really well, for those of us that don't, here's a quick introduction. So AnyLogic is a leading multi-method simulation platform. It combines the three main simulation paradigms of discrete event, agent-based and systems dynamics modeling. It has a range of out-of-the-box features, including industry-specific libraries for process modeling, material handling, pedestrian simulation, and many more. We'll be touching upon the new features of the rail and material handling library in the next slide, and then really getting into the detail of the material handling library features as the webinar progresses. It's worth mentioning that it also integrates geographic information systems maps, as well as providing 2D and 3D visualization and animation capabilities to really help communicate model results and analysis. For a full list of features, have a little look at the AnyLogic link in the slide below. We're really proud to be able to introduce you to the latest release of AnyLogic as a part of this webinar. Version 8.6 is due out in mid-July and comes packed with a load of new features, including multiple enhancements for the MHL and the rail libraries. Additional features to the MHL include access and speed restricted areas for entities like AGVs, continuous and batch processing of items on conveyor stations, and additional options for moving transporters to a particular holding node in space markup after it has been released from the work that it's doing. Alongside MHL, there are also new additions to the rail library, and these include things like double sling and single sling switches that allow you to connect to more than 3 railway tracks at the same time. Tracks can now be blocked or reserved for a particular train, and train movement can be paused and then restarted, removing the need for multiple train move to blocks. So now that we've heard a little bit about AnyLogic as a simulation platform and some of its capabilities, I thought I'd also tell you a little bit about DSE as well. We've been a sole technology partner to the AnyLogic company since 2008 in the UK, and we've recently begun to serve the Italian market with our range of technologies and support as well. The core platforms we use are of course AnyLogic and AnyLogistics. However, our technical specialists, including Kelvin, who's with us on this webinar, have recently been using AnyLogic models with complementary AI platforms like Bonsai and Pathmind. As a technology adoption and support services company, we offer a range of services including bespoke modeling, official training, one-to-one mentoring, model auditing, amongst others. The whole team have a deep expertise in data analytics, and we come from a range of backgrounds including aerospace, manufacturing and healthcare, as well as historically working across a range of discrete event and agent-based simulation products too. We also act as a bridge for our sister company Decision Lab, who offer a wide range of data science and optimization services, normally developed as end-to-end solutions that work within existing cloud-based frameworks. There'll be a link to them at the end, so if you fancy looking at that, please do. And I'm now going to be handing over to Jock to talk to you a little bit about Growpura.
Thanks, Anand. Hi, everyone, and welcome. My name is Jock Richardson from Growpura. Great to be with you. We've been interested in hydroponics for quite a few years now, and have spent a lot of time thinking about what the ideal hydroponic system looks like. In recent years, we've seen a lot of excitement about the possibilities of hydroponics. It's a fascinating area, and we take a somewhat unique view of what the ideal system looks like. Far from just creating a good growing system, we view plant production as a factory system, requiring low operating and capital costs, but also considering the entire process from seed germination to delivery of a product to the client. Importantly, all of this has to be done in a way that gives back to the environment, and so there's a lot to think about. Our system, briefly, it's a moving system. It's a little different. Normally in hydroponic systems you see static trays sitting on benches, and you have to take a lot of infrastructure to that tray. So, for example, lighting, irrigation needs to be taken to every individual plant. The advantage of a moving system, well, there are many, but philosophically it's about taking the plant to where it needs to have something done to it, for example, irrigation or harvesting. The other advantages of it are that we eliminate or minimise disease hotspots. You never have a plant sitting in the same part of a growing hall for any long period of time. They simply keep on moving around, and so never experience quite the same environmental conditions. And this has certain advantages in terms of plant growth and the quality of the plant at the end of the growing process. We're building a facility to the north of London, near Bedford, where we'll be producing several thousand tonnes of product a year. It's a big operation. And as you can imagine, a system like this needs careful modelling and simulation to understand everything that's going on within it. So we're really glad to be working with DSE, and the work we've done so far has been great. I'm going to hand back now to Anand, and I'll chat to you a little bit later. Thank you.
Thanks, Jock, for the interesting introduction to Growpura. It's great to see all of the innovative hydroponic solutions that you guys are creating for sustainable operations in the UK. Before we get into the detail on how MHL has been applied in Growpura's case, we're going to hand over to Kelvin, and he's going to take us some of the material handling library simulations that he's packaged up for you in a novel little form using a pocket handbook.
Thank you, Anand. And hello, what's up, guys? Welcome to this webinar, and today I will be giving you an overview of the MHL, demonstrating some simple use case and show you some of the cool new features available in AnyLogic 8.6. If you haven't done so, please follow us on LinkedIn, and you will be able to see some of the cool projects that we did. AnyLogic's material handling library lets you simulate and analyze end-to-end processes on factory floors and storage facilities. In a nutshell, material handling library lets you simulate movement of goods with conveyors, transporters, and cranes with its out-of-the-box functionalities. You can evaluate warehouse or factory layout alternatives, simulate processes in warehouse or factories, including the conveyor system, cranes, and AGV fleets. Analyze the performance of different production line designs and test their capacity for production. My assumption is that you are already familiar with the AnyLogic user interface, and you know process modeling library, so we don't start from the beginning. If you are not familiar with those two concepts, I strongly recommend you to look at the introductory webinars on the AnyLogic website, and to use the AnyLogic support function if you can. If you are a beginner to AnyLogic and would like to learn more about the MHL, this is the right place for you. So let's get started. I'll see you in a bit. Imagine you are back to when you were 6 years old and you are trying to build your very own Lego model. What does it feel like? The excitement and passion drive you to create your very own model, where you think nothing in the world can be better than that. Until your elder brother just came into the room and showed you this. At this moment, you realize that just having creativity alone will not get you very far. You need to learn to use and utilize each of the Lego blocks before you can go up another level. you need a book or catalog that tells or reminds you what each of them do. And for this reason, I'm introducing the MHL Pocket Handbook, which is free to download on our website. You can also access it via the AnyLogic cloud. What you are seeing here today is something very simple but unique. We created this handbook to demonstrate to you what each block does using the most simplistic arrangement possible. Any comments, feel free to contact us and leave us a message. If the overall feedback is positive, I am intending to create the Pocket Edition for the other libraries as well. Enough talk, let's dive right in. So in here, we can see the front page of the MHL handbook. It contains the blocks where you can click onto each of them and it will show you some simple use cases. You can find these blocks in the MHL. By the end of this video, you should have a general understanding of the MHL. Let's look at the first block, Conveyor. Conveyor is the space markup shape that graphically defines a conveyor. You can simulate how material items are transported by conveyors using the AnyLogic material handling library blocks. Conveyor starts with the defined initial speed and accelerates to the defined maximum speed, keeping it until stops. By default, the roller conveyor is used, but if required, you can set it to any available type. There are 3 types available. The roller type, which is an accumulating type of a conveyor. If an agent is stopped on it, the rollers will keep on rolling, bringing all the preceding materials to the stopped one, thus forming a line of agents. The belt type is a non-accumulating type of a conveyor. If an agent is stopped, the whole conveyor stops to prevent collision of material items. The fixed cell type is again not an accumulating type of a conveyor. The conveyor is a succession of cells of specified size. Material item is placed inside the conveyor cell, and one conveyor cell can contain only one material item. If an agent stops, the whole conveyor stops. Conveyor spur. Conveyor spur is the space markup element that is used to define a junction between a branch conveyor and the main conveyor. Agents passing through it keeps their current orientation on conveyor. The transfer of material items from branch conveyor onto the main conveyor is automatically calculated so that it does not affect the normal operation of the main conveyor. If necessary, the material item on the branch conveyor will be delayed until the flows of both conveyors can be safely merged. The merge is executed at maximum speed of the main conveyor. Transfer table. Transfer table is the space markup element that is used to define transfer tables in the material handling models. Agents passing through it keep the current orientation in space. Once placed on a conveyor, the transfer table divides it into 2 independent conveyors working in the same conveyor network. Transfer table may connect up to 4 conveyors at right angle. Transfer table has its own transportation speed, and the time required to switch to another conveyor can be defined by the switching delay parameter. Turntable. Turntable is a graphical space markup element that is used to define turntables. Agents passing through it keep their current orientation on the conveyor. Once placed on the conveyor, the turntable divides it into 2 independent conveyors, working in the same conveyor network. Turntable may connect unlimited number of conveyors at any angle. Turntable has its own transportation speed, and the time required to switch to another conveyor can be defined by setting the rotation speed of the turntable. The difference between conveyor spur and turntable is that conveyor spur will instantly change the direction of the agent, whereas the turntable will take account of the rotational time. Turn station. Turn station is a graphical space markup element that is used to define turn station. Turn station rotates agents passing through it. Items can be rotated by any angle that is divisible by 90 degrees. Once placed on a conveyor, the turn station divides it into two independent conveyors working in the same conveyor network. Turn station can connect only two conveyors forming a straight line. Turn station has its own transportation speed, and the time required to switch to another conveyor can be defined by setting the rotation speed of the turn station. Station. Use the station space markup element to draw a simple processing station on a conveyor. The installed station doesn't break the conveyor into two conveyors. The station can process more than one material item at a time. The maximum number of material items it can hold inside simultaneously is defined by the capacity parameter. The station has two processing modes in version 8.6. The first one is the processing starts when capacity is full. The station accumulates material items until its full capacity is reached and then processes all of them simultaneously. This is the only mode available before AnyLogic version 8.6. In this latest version, a new mode is supported. Processing can now start when agent enters station. The station starts to process each material item individually as soon as its leading edge enters the station. For each material item, the processing will last for the specified time. During processing, the material item keeps moving through the station until it reaches the exit, where it stops and waits until the processing is completed. Then it leaves the station if another material item doesn't block its way out. The station can accommodate as many material items as defined by the capacity parameter, but all of them can be in different stages of processing. The time required to process the specified number of material items is defined by the delay parameter. Custom station. Custom station is a space markup element used in material handling models. It defines a station or working zone where material items are processed. The process is not set up in this element. You should define it on your own. Custom station can act as a transit point in a conveyor network. Any number of conveyors can lead to or from the custom station. Custom station is drawn as a polygonal area. The shape and size of the area does not have any logical meaning. The jib crane. The jib crane is a space markup element that graphically defines the tower crane. You can use the material handling library block, the move by crane, to simulate how the crane transports agents between 2 points of simulated environment. Jib crane has two different modes of operation depending on how its components move in relation to each other. The first one is step by step. The components will move one at a time. And the second mode is concurrent mode. The movement of all components will be executed at the same time. This model is showing the step-by-step mode. The maximum height of an agent that can reach when raised by the jib crane equals the height of the crane itself. The jib crane element provides users with a set of actions which are used to define additional agent behavior. The overhead crane. The overhead crane is the space markup element that graphically defines an overhead crane. You can use the material handling library block, the move by crane, to simulate how the overhead crane transport agents between 2 points of simulated environment. Crane has 3 different modes of operation depending on how its components move in relation to each other. Again, step by step and concurrent as previous Jeep Crane 1 as before. And the third one is independent hoist. The movement of the bridge and the trolley is executed at the same time, either before or after the movement of the hoist. The maximum height an agent can reach when raised by the overhead crane is equal to the height of the crane itself again. The rails of the overhead crane here can serve as an obstacle on the way of transporter moving in free space navigation mode, but they can still move between the rails. Overhead crane element provides user with a set of actions which are used to define additional agent behavior as well. The lift. The lift is a space markup shape that graphically defines a vertical reciprocating conveyor. And at the moment, only 2 types of network support this element. They are the standard process modeling library and the MHL library. Transporters with free space navigation mode can enter the lift from any side, and to restrict their movement, we need to draw the walls which will impede the movement of transporter where it is necessary. To simulate a lift, you have to place several lift elements, and 1 per level. One of the lift elements is used as the main landing. All parameter lifting speed, the pickup time, etc. are specified for this element only. The level gate, which is quite an interesting one to show, I think. Not sure if any of you have played Portal before, but the level gate essentially replicates the same idea. Level gate enables the movement of transporters with free space navigation between different levels. Level gates always operate in pairs. To create a pair of connected level gates, you have to specify one of them in the other gate's properties. Level gates are represented as lines, as you can see in the 2D views here. The length of the line is a visual marker of a passage through which transporter can move to another level. The gate length can be increased or decreased, but if the pair gates have different lengths, the transporter will move within the length limit of the shorter gate. The length limit is calculated from the starting point of the level gate. The transporter fleet. This model demonstrates how you can move a transporter from its home location, pick up the specified agent, the red circle in the model, and bring it to the destination, red cross in the model, then return to the specified location. There are 2 new features introduced in AnyLogic 8.6, which is the restricted area and the new parking location. We can specify a restricted area by drawing a polygonal node, and you can customize the access to the node and the speed of movement through the node for transporter with free space navigation and path guided navigation. Speed restriction and access restriction do not depend on each other and can be specified separately. The nodes with different restriction can overlap each other. In this model, the restricted area only allows 1 transporter to go in at a time. The other new feature is that instead of forcing the transporter to go either return to home location, return to the nearest home location, or stays where it is, we can now have an option to set a particular node where the transporter should go after it is released. So in here, this is the new location I specified. So We have pretty much gone through all the core blocks of the material handling library. Are you ready to build your own block yet? Once you have a good understanding on what each block does, I think you can start to build and customize your own one. So in this model, the Lego block does nothing more than what a normal conveyor block can do. If I just click on that, you can see it basically just connected to one conveyor block. It basically transports a material item from one place to another. But as you can see, you can make the block more intelligent by utilizing the blocks from other libraries. You can even develop your own personal library. I use this model to demonstrate the network port object. It enables the movement of transporters between separate standard process modeling library networks, or the movement of material items between separate MHL conveyor networks that have basically no physical connection. One network port can only be connected to one network path or conveyor. Network ports always operate in pairs. To create a pair of connected ports, you have to specify one of them in the other port's parameter. The paired ports can exist either on the same level or on different levels in the model hierarchy. I believe that's the end of the MHL blocks demonstration. At the end of the day, you might be able to put together something like this, which is really close to what you want it to be. But if you really want a perfect model, just remember, ask for help and consult the expertise.
Thanks, Kelvin, for sharing the Pocket Notebook with us and for showing us some of the existing and new features that are coming out in version 8.6. That model will be available to download, so we'll be sharing a link with you guys at the end of the webinar for that. And now I'm just going to be passing over to Jock, who's going to be setting the scene a little bit for us in terms of process and showing you a little bit about how MHL was applied within Growpura's model.
Hi everyone, Jock again. So we initially engaged DSE to look at modelling our system from a quick and dirty point of view, if you like, just to understand how a modelling architecture might evolve, and also just to do an initial test on our system, just to understand how queues might form, for example. So to do that, we obviously have to give DSE guys a bit of information about our facility. So to describe, we've got three main areas depicted here on the slide, and the first one, we've got a propagation and germination area in which seeds are germinated and then grown to a certain stage before they're transplanted into the main growing hall. As they go through that propagation stage, you can imagine the plants are getting a little bigger, and so the density, the plant density in trays increase. Well, it needs to be reduced to allow for the increased plant size. So that's one of the processes we have to achieve, is transplanting plants from one density tray to a lower density tray. And then at some stage, once those plants are ready, they're then moved into the biohall. In the biohall, we have what we call gondolas, which are essentially large trolleys, which have a stack of vertical trays that move constantly around the hall. As I mentioned earlier, we have a single irrigation point. We don't need as many lights because the gondolas can move past a light source. So there are numerous advantages to this, as I've mentioned, not least of which is the reduced lighting cost. We don't need as many LEDs, and it's also supplemented by natural sunlight. So yes, plants go into the main growing hall. They get watered as often as they need to, every few hours if necessary. They also spend some time in what we call it, we'll call it the nighttime area, where they receive a bit of dark time, where they're not constantly being subjected to light. So that's kind of two separate areas, but we can consider that the general growing environment for a plant during the last stage of its life. Once the plant is ready for harvest, it's then sent to the harvest area, prepared for harvest in a certain way, and then sent to the harvest area where obviously it's harvested and packaged and sent out to customers. So this is very much a factory type of process. We need to consider what the presentation of the plant needs to look like for customers. We need to think about specifications for customers, how narrow those specifications might be, what sort of profile of specification the customer might want. So we need a lot of flexibility in the way we can grow plants. And this system provides that. And the modelling, most importantly, provides our understanding of how to achieve that. So how many seeds should we plant on day 1 or day 10? When should we transplant? And we can also control the growth of plants. We can slow plant growth down if we need to. We can do all sorts of interesting things. The other thing we're doing is capturing an enormous amount of plant data, plant growth data. So as you can imagine, all those plants moving around the system, you can just have a single camera taking a picture of every single plant as it goes past. So it's very efficient from that point of view, and we're going to have some really interesting data that comes out of that. The modelling itself that we've done with DSE, it worked from a ground up point of view, but in future, well, no, we're doing it now. We're looking at high level abstractions of, for example, how might a demand model affect the way we germinate seeds? And there's all sorts of interesting work being done in that area. So we're looking at several models that we're building, and yeah, there's a lot to do. There's a lot of recursive calculations needed. So it's an iterative process that's going to take some time, but at the end of it, we're going to understand our system really well. So I'm going to leave it there, hand over to Kelvin, and thank you very much.
Thank you, Jock. So let's look at the model now. As Jock has mentioned, we DSE Consulting developed a model for Growpura with the aim to optimize the operation of hydroponic solutions. We looked at the utilization of resources, costs and revenue, etc. But due to IP issue, we will only be able to share the simplified version of the model today. The layout in this model does not reflect 100% to what it should look like, but the logic behind stays the same. Before running the model, I will just quickly recap on the few key areas of the site. In the top left-hand corner, we have the seeding area. This is the area where the empty trays are being seeded. In this model, the seed types are Apollo and Basil. Once seeded, they will be carried by the AGVs to the germination area. And this applies the same for the grow area here. They will stay for a period of time. Before loading them up to the conveyor system, the plant trays will be brought to the storage system and sit there until it is ready. In here we can see the carousel system, which is used to load the plant trays to the gondolas. Each gondola on the conveyor system can carry up to 20 plant trays. They are then cycled around the conveyor system to grow. The area marked by the blue square is the grow area for Apollo. Only gondolas with Apollo can enter this zone, while the area marked by the orange square is the grow area for Basil. And again, only gondolas with Basil can enter this zone. After cycling around the grow area for a fixed period of time, they will then brought to the middle section here, the dark room, for another period of time. So this process repeats continuously, depends on the plant type. When the plants are ready to harvest, the gondolas will be brought to the unloading area here, where trays of plants will be unloaded by the carousel. The AGV will then pick up the plant trays and move them to the cutting area. The used tray will then be washed in here and then be reused in the seeding area. So if I run the model now, you can see gondolas colored in black being loaded up onto the system. Once the plants are loaded, the gondolas will be colored depending on the plant type, blue for Apollo and orange for Basil. Now, one thing I haven't mentioned is that I've improved the model by utilizing the new features in version 8.6. The weighing station in here originally need to wait until a certain capacity is reached before starting the weighing process. With the latest AnyLogic version, I can now start this weighing process as soon as the plant trays are in the station. And in here, in the unloading area, I have placed a restricted area to limit the amount of AGVs. So there will only be a certain amount of AGVs allowed in the area. Now let's have a quick look at the model logic. For beginners, looking at the model might seem terrifying in the first glance. However, if you look carefully, we have pretty much covered most of the concepts. All the blocks in purple can be found in the material handling library, while the blue ones are from the process modeling library, these ones. They should look fairly familiar to you, as we have just looked at those in the previous section. Remember the source block where we generate the agent, like this one here. And then remember the conveyor block that is used to transport the agent on the conveyor system, like these ones. And the move by transporter block that is used to seize a transporter, which is here. And in this case, we're seizing AGVs. The other interesting thing you might find is that I have made a few custom blocks here. The germination area, grow zone, tray loading, darkroom shuffling, grow area, recycling, these two, and then harvesting, and then what else? Cutting and tray washing. The good thing about AnyLogic is that you can build this model as simple as you want or as detailed as you wish. If you got time, you can pin down to every single detail of a process. The custom block can be as complicated as you want it to be. One inspiring idea though, no matter which industry, whether hydroponics or aerospace or rail or agriculture, is to have a common standard of building these AnyLogic blocks. If everyone used AnyLogic for modeling, then nothing will stop them to create their own block with their domain knowledge. For example, in this model, we can further enhance the accuracy of the tray washing process here by using the blocks provided by the tray washing company who made those tray washing machines, for example, if they use AnyLogic, of course. The idea is simple. If everyone builds their own catalog of Lego blocks and share amongst each other, the closer we are to create the perfect model. So let's spend a little bit of time to look at the 3D view. We have created multiple tabs, as you can see, with the intention to highlight specific areas of the model. The good thing is that these 3D objects are readily available in AnyLogic, which means that we don't actually need to create them ourselves. However, if you want to have a custom object, you can easily do so by importing the file in DAE format. In here, the gondolas are custom objects. They look like a tower with flaps extending out. The plant trays are loaded onto those flaps, which then gets cycled around the system. In the Dashboard tab, it records the KPI of the model on the go. It is a good place for us to sense check the model and see if it is behaving as expected. In here, it records the number of trays over time, number of trays in specific areas, the trays in waiting area, utilization, cost and revenue, etc. Bear in mind that in most of this situation, especially for validation and verification process, you might run different experiment instead of this plain one. In a Monte Carlo run, for example, multiple instances of the model will run in parallel, and you can actually export the raw data to the pre-built AnyLogic database or an Excel file. I personally prefer Excel file, as you can easily format the data to whatever style you want. So I think this is the end of the demo. I hope you enjoyed it, and hopefully this has given you an overview of the MHL and how the MHL can be applied to real-life scenario. Now we're switching back to live mode, and I'll pass this back to Anand to conclude the webinar. Thank you.
Hi everybody, sorry about that, I was still on mute. Hopefully you guys got something really interesting out of that webinar, both in terms of the types of models that we're making and also some of the features that are coming out in the new version of 8.6. Just to give you a little bit of insight into where you can get some of these things from. So the MHL Pocket Handbook is going to be available on our website. It's also available on AnyLogic's cloud. Of course, if you're looking for a version of AnyLogic, feel free to go to the AnyLogic website. The new version, 8.6, is due out in mid-July, as we mentioned in the webinar. So please have a look at that. We've got Jock with us online, as you can hopefully see, and Kelvin, who was presenting in the webinar as well. So if you'd like to learn a little bit more about Growpura, or if you have any questions on the Growpura system and some of the innovative hydroponics solutions they're creating, feel free to send us some questions, and of course check out his website at growpura.com and also h2organics.co.uk. And lastly, one last plug from me. If you're looking for some wider AI and data science services, then we also have a sister company called Decision Lab. You'll find a couple of their case studies on the AnyLogic website, but feel free to have a look at their link and drop them a line if you're interested. Okay, so on that note, I guess I'll open up the floor to any questions. I don't know if we've got any specifically, gents, that we want to answer immediately. It looks like there's one from Vinay on GIS integrations. Calvin, I don't know whether you want to pick that one up very quickly.
GIS integration is not included in this webinar, but obviously AnyLogic is capable to do GIS integration, and we have done multiple projects on that as well. So the GIS function is already a pre-built block within AnyLogic. You basically use the map routing you can use the AnyLogic pre-built map routing, or you can use your own shape file, etc. And most of the time you use the GIS to model supply chain kind of projects, for example, warehouse and factories where you got trucks maybe moving and using the fastest routes, etc. So I hope that answers the GIS integration question.
Thanks. Thanks.
Or is there any specific about the GIS integration? Feel free to follow up. And then I see some of the question about how did you integrate the processes? So there are 3 different processes. So yes, that's a valid question. So that's a good question. I guess this is basically how do you pass agent around different places. If you look into the model processing library, for example, those blue blocks, in one of the blocks you can there's like an enter and exit block, which allows you to pass agents around. And if you are doing an object-oriented style to build your agents, then passing these agents around should be fairly straightforward. For example, agents take that agent basically using the block from the process modeling library.
So it looks like we've got a question from Nick Bateman as well on hydroponics. So Jock, I guess this will be for you. So let me ask the question. So Nick's just asking, well, first there's a statement that says the hydroponic model seems very scalable. And and then he's gone on to ask, how would you work with DSC and AnyLogic to help businesses who want to implement your approach?
Yes.
Sorry, it might be a she, it may not be a he.
Sorry?
I said it may not be a he, it may be a she. It might be just.
It's all good. So yeah, it's obviously a more general question, even though this is probably a pretty technical audience. But for us, working with you guys and trying to model this process it's quite interesting. Where do you start? And so we look to you guys for some guidance. But essentially, what the approach we're taking is to kind of start from the demand point of view, and we'll work backwards from there. So what does a demand model look like? And if it's a simple sink where you've just got product flowing straight into a sink, then that's a lot simpler than having to model demand for different days of the week and all this sort of thing. So that for the non-technical people, the people who are interested in the general concept of how we work with DSC and AnyLogic, that gives you an idea of the potential for complexity to enter this. So it becomes quite important to understand the architecture of your modeling solution before you even start trying to model anything from the ground up. You need to understand what sort of abstractions might be useful in defining the appropriate architecture. And yeah, there's a lot of preparatory work that goes into it. But as anyone would know who's done this sort of work, even though this might not seem practical work of putting things in place, as Kelvin says, it's like Lego blocks. If we understand it from that Lego block point of view early on, it just makes our work so much easier down the path when it comes to implementation. Anand, do you want to add anything there? Is that a reasonable?
No, I think that was a really, really great answer, Jock. And actually, there's another question that came in from Manuel to Cole. And I think you've touched upon some of the questions the question that he had, which was about application to actual implementation. So how efficient was AnyLogic in the application that you've discussed? So, I mean, I guess as we mentioned at the beginning, the model is essentially a proof of concept, but hopefully, and I'm sure Jock will elucidate on this, but hopefully it's something that's come in handy based on the level of abstraction that was built into it to helping him at least inform some of his decision making within the way the plant is going to operate and also its sustainability.
Yeah, absolutely. When you develop a model like this, this is just a starting point for us. This helps us understand, uncover the further issues we've got to look at in more detail. So we're always modeling towards a solution. We're not expecting the absolute answer on the first shot. So yeah, it takes a bit of a process, but that's where having some clever minds around the table, not just thinking about modeling itself, but actual architecture is really helpful.
Calvin, was there anything you wanted to add or any other questions you want to pick up on quickly?
Yeah, but obviously we can follow up all, because I see that there are quite a few ones, but I think we can follow up all of them later on. Let me just randomly pick one now, because they're like a huge list. Nuclear, okay. Have you done any work in making isotopes in a nuclear research reactor? I guess that's a question for me then. No, I haven't worked on nuclear stuff. But actually, in fact, I did in my master. I actually my major is in actually nuclear reactor physics, basically. But I haven't done any. I haven't used AnyLogic to do any modeling for nuclear research reactor. But then that shouldn't be relating to the MXL. I think if you need to model this kind of stuff, you use a more high-level block using the process modeling library or system dynamics, which you can do to do differential equation, etc. Which I think, well, there must be loads of them in the nuclear.
Yeah, absolutely. I was going to just as an addendum to what you were saying, Calvin. I think you kind of said it anyway. Was although it's maybe not MHL related, it's certainly something that you could use AnyLogic to produce if you were looking at the process within a nuclear reactor. So Okay.
And then,
well, sorry.
yes, so one final one, because there's just one right at the bottom. So in the demo, you must have agents. We cannot just use the DES from a flowchart plus MHL, or can we? Yes, well, obviously MHL is already an agent-based kind of library. If you drag and drop the conveyor, it's already, it's different style to process modeling library, where in process modeling library, you separate into space markup and the actual block to make the thing visualize. But in MHL, the whole thing, the conveyor is actually an agent. If you think of it that way, the station is an agent. You can actually click on the station and change the parameter within that. So in short, so yeah, to use the MHL is more agent-based kind of modeling. But if you want a high-level abstraction method to doing the model, it works as well using the process modeling library and system dynamics, as I mentioned. Yeah, I think that's it.
I think we've got a question there on the, are there any case studies available about MHL? So yes, there are. We have many on the website, and there'll be a follow-up email to this webinar, and we'll make sure that we link to where you can get those as well.
Great. Okay. Well, there's a lot more questions there, but I'm afraid we're probably going to start to run out of time, and some of them are quite detailed as well in terms of what people are asking for regarding 3D and collider files and stuff like that. I mean, I could talk to you about collider files for a rather long time, but I'm afraid I might put you to sleep, and in this hot weather it'll be heat stroke. So it might be a good time to say thank you very much, and hopefully we'll be able to pick up on all of these questions at a later date. Gavin, I'll let you wrap up if that's okay.
Yeah, I just wanted to, maybe I missed it, but I just wanted to reiterate that the handbook that Kelvin showed will be, or is already available on the DSE website. So you can see the link there, yeah. And we'll link that in the follow-up email as well. And there'll be a recording of this webinar today. So I hope everybody enjoyed it, and if there's nothing else to add for now, then thank you everybody for attending. Thank you, Jock, for allowing us to see the hydroponic setup that you've got there, and thank you, DSE, for all the effort and for presenting the webinar with us today.
Pleasure. Thanks, guys.
Thank you.
Take care. Goodbye. Goodbye.